Chris. I'm a second-year biological sciences student from the University of Exeter, and for the past 8 weeks I've been based here at Rothamsted Research, investigating the historic presence, current distribution and fungicide sensitivity of a wheat pathogen called Rhizoctonia cerealis. Rhizoctonia cerealis is a fungus that lives both in the soil on decaying plant matter and on the stems of cereal crops like wheat. When it infects, it causes these distinctive necrotic lesions with dark defined borders, which we call sharp eye spot. In the UK, sharp eye spot symptoms have been reported on winter wheat stems since the 1930s, typically affecting about 2 to 20% of stems in visual surveys. And while average yield losses are usually low, so about less than 0.5% each year, severe outbreaks can be devastating, causing losses of up to 25%. What drives this year-on-year and regional variation in prevalence and damage is currently poorly understood. There are some suggestions that climate change, altered fungicide use, and different sowing dates could be increasing sharp eye spot severity globally. However, there are two key barriers in understanding these factors. So firstly, in accurately identifying Rhizoctonia cerealis in the field, and then secondly, a lack of long-term data on its prevalence. So sharp eye spot lesions can often look really similar to those caused by several other fungi that also infect the stem base, and some of those fungi can be more damaging and differentially sensitive to fungicides. And this makes it incredibly difficult for farmers to pinpoint the exact causal species of symptoms they're seeing in the field and choose the most appropriate management, like deciding if and what type of fungicide to apply. It also makes it really difficult to accurately track these pathogens over time using visual symptoms alone. So during my project here at Rothamsted, my goal was to overcome these challenges by documenting the current and historic presence of Rhizoctonia cerealis in the UK using quantitative PCR, or qPCR. This technique allows me to identify unique DNA sequences specific to Rhizoctonia cerealis in plant samples, which is a far more accurate identification method than relying on visual disease symptoms alone. So for the current distribution part of my project, I applied this qPCR technique to DNA samples extracted from infected wheat stems collected from throughout the UK between 2022 and 2024, and kindly provided by ADAS as part of the UK Pest and Disease Survey. And my results from these assays show that Rhizoctonia cerealis is an exceedingly sporadic disease. Despite testing many samples with sharp eye spot-like symptoms, only a handful actually tested positive for Rhizoctonia cerealis. For the historic distribution part of my project, I used the same qPCR assay to test DNA samples from wheat stems which have been archived every year since 1844 from a single field right here at Rothamsted called Brookman, which is the longest running scientific experiment in the world. The stem samples I tested are stored right here in the Rothamsted Sample Archive, alongside almost 300,000 others, with new material added continually. With the advent of modern molecular techniques like qPCR, we can now investigate these archives using groundbreaking ways, providing an invaluable, globally unique resource for understanding long-term disease dynamics. Historical literature states that sharp eye spot symptoms were first reported here at Rothamsted in 1935, but Rhizoctonia cerealis wasn't officially named as the cause until 1977. However, using qPCR on the broadbox stem samples, I detected our cerealis as early as 1960, with similar sporadic distribution in later years. This further confirms its rare nature and the historical difficulty in identifying the species using only visual methods. As part of this project, I also investigated how different isolates of Rhizoctonia cerealis respond to fungicides with various modes of action used in the UK for disease management, by growing them on fungicide-treated agar plates. This helps us to understand and monitor potential fungicide resistance in this species. In addition to these experiments, I also had the opportunity to survey more recent field experiments here at Rothamsted for disease. This meant following the full process, from collecting samples in the field, to isolating fungi, extracting their DNA, and finally using qPCR for species identification. This experience has allowed me to create a valuable library of fungal isolates, each associated with photographs of the lesions they originated from. This resource will be maintained here at Rothamsted for future research and could significantly help us to understand how stem-based symptoms correlate with different fungal species. So the key findings from my project are that Rhizoctonia cerealis appears to be a relatively minor cereal stem pathogen in the UK, being found only rarely and at certain locations. However, Given recent changes in the climate, it's possible that the pathogens associated with cereal stem-based diseases may change in their importance, highlighting the need for ongoing monitoring to improve disease management. Beyond Rhizoctonia cerealis being a pathogen in its own right, its interaction and potential competition with other stem-based pathogens could also influence overall disease dynamics in the field, and this remains an area that needs more research. I've really enjoyed my placement here and developing my confidence in the lab. And being surrounded by the student community at Rothamsted and people at various stages in their careers has opened my eyes to the range of roles in research and allowed me to explore ideas about my own steps after I graduate. I also had the opportunity to attend various conferences and events with farmers during my time here, which has allowed me to better appreciate how scientists and farmers can inform each other's work, and the importance of this communication to ensure research is meaningful. I'd really like to thank my supervisor, Fareed Bhatti, for organising this project and supporting me throughout it, and John West, Kevin King and Gail Canning and the rest of the team for all the invaluable advice and support they've provided to me throughout my time here. I'm incredibly grateful to the British Society for Plant Pathology for funding this project, and if you'd like to read my full report on my placement, you can find it on the BSPP website.